Hello everyone, welcome to this demo of network analysis from Infigo Software Solution Limited. So let's start by quickly understanding the agenda. So first one is introduction to AML, which is anti-money laundering system. So it's a set of rules and technologies to stop criminals from turning illegal money into legal money. The next one is KYC slash CDD. So know your customer meaning know your customer and customer due diligence means verifying a customer's identity and background before doing business with them. The next one is sanction screening, means checking if a customer is blacklisted or flagged by a global authorities. The next key point is AI and ML model-based prediction for AML. It means using artificial intelligence and machine learning to predict if a transaction looks suspicious or not. The next key point is anomalies indicating the probability of AML, meaning these are unusual patterns in transactions that may signal fraud or money laundering. The next key point is network analysis and fraud ring indicator of AML, meaning studying connections between people, accounts, and entities to detect hidden fraud groups. The next key point is data profiling for investigation of AML transaction, meaning creating a detailed view of customers and their transactions for investigations. The next key point is beneficiary ownership detection, meaning finding out who really owns a control a company, meaning finding out who really owns or controls a company or account. The next key point is transaction filtering, monitoring, and reporting, meaning keeping watch on all transactions and reporting suspicious ones. And the last key point of this agenda is case management system, which is a system to track investigations and manage alerts efficiently. So let's go to next slide. The next slide, here we can see the flow diagram of AML. These are the six components in this architecture. So first component is KYC and sanction check. These steps checks every customer against global blacklist and watch list. If there's a strong match, the system blocks the account or transaction instantly to prevent risky activity. The next one is data ingestion layer. Here, data from banks, Swift, and crypto platform is pulled in real time. It's a clean and standardized into one format so the system can analyze it smoothly. The next one is AI-driven risk scoring. This system uses machine learning to score transactions. The next one is network analysis. This part uses advanced graph techniques to map relationships between people and account. The next one is case management and decisioning. This can low risk alerts. Here we can see low risk alerts gets closed automatically while high risk ones to get investigators. And the last component of this architecture is regulatory reporting. Finally, the systems prepares official suspicious activity reports with an R. Now let's move to the demo. So with that foundation, let's here we can see the demo. So this tool helps visualize and analyze transaction networks to spot the potential money laundering. We can see the network analysis option here. Let's we can see the select analysis type. By default it is of two variable network. We can also set it into multivariable network. Then we can see here upload a CSV file. We can drag and drop file here and also browse file here. Let's browse file. Here we can select a CSV file. Now the main screen appears. Fraud network analysis tool with a dataset preview table showing sample data like transaction ID, customer ID, timestamp, transaction amount, and so on. So it's a two. Let's go next. This one is uh, this one is two variable network options. Here we have to select first variable, second variable, and target variable. So let's select first origin country. For a second variable, we can select destination country, and for target variable, we can select suspicious flag. Number of networks to display. Uh, Here, number of network to display dropdown set to by default 50. This simply means how many separate network graphs or visualization the app will show you after running the analysis. Here are the options go from 10 up to 1000 depending on how detailed we want the output. So we can select to 50, and the next one is model training options. Here the by default algorithm is random forest. Here are three machine learning algorithms. First one is random forest, decision tree, and neural network. First we can see by random forest, and this is the number of epochs. This is number of epochs means we can see here uh, 300 by default, and it is ranging from 100 to 1000. So number of epochs refer to how many times the machine learning model goes through the entire dataset during training. More epochs can improve accuracy. So at the bottom, here's a run network analysis button to start the process. Let's click on this button. Here we can see node centrality measures. So node centrality measure table are metrics that shows how important or influential each node is. So like country or transaction type is in network. It lists nodes like South Africa, UAE, India, and etc. With the degree centrality, how with degree centrality means how many direct connections a node has. Then the next one is between this centrality means how often a node lies in the shortest path between others. And the last column is closeness centrality means how close a node is to all others means me, higher means quicker reach. Now here is the random forest accuracy which we selected before, which is 90%, meaning the model correctly predicted 90% of the cases. The next one is Leuven community detection graph. Here, Leuven community detection is an algorithm that groups nodes into communities based on how densely connected they are, helping spot clusters like fraud rings. It maximizes a score called modularity. In this graph, South Africa is the central one node connected to China, Nigeria, India, UAE, and Switzerland, with edges labeled to 0 except this one, uh, which is of red color. So the path of South Africa and UAE is of fraud node. The next one is lead-in community detection graph. Lead-in community detection is an improved version of Louvain that finds more stable and higher quality communities by refining partitions. It's faster and avoids some Louvain pitfalls. This blue graph shows similar structure like lead-in, but here is a red node which is of fraud node. which indicates fraud, which is of South Africa to Asia. The next one is table of network edge details. This list connect edges in the network with source like South Africa and target like South Africa, UAE, India, Nigeria, Switzerland, and China. All are in label, all are zero here except the label of South Africa and UAE, which shows the fraud node. Now let's shift to next model, which is decision tree, and let's do the number of epochs, which is 350, and run network analysis. Here also we can see the node centrality measures of South Africa, which connects to the UAE of Leuven community detection, and in Leiden community detection here also we can see the fraud indicate node of South Africa to UAE, and here also network edge details. Here we can see the South Africa to UAE, which is of target column and the label 1. Let's select to the last training model, which is of neural network, and run network analysis. Here also the same Leuven community detection graph of 1 indicate to fraud, which is of South Africa to UAE, and the Leiden community detection of 1, which is indicate to South Africa to UAE. Now shift to multivariable network. So here we can uh, here we can see multivariable network options. Uh, let's select multiple input features column like transaction amount, transaction type, origin country, and destination country. Our target column is already selected. Number of networks to display. Let's set to 50. Model training. Let's random forest. Let's select random forest and number of epochs 350 and run network analysis. Wait some time, it is running. It will not take so much time. Here we can see the node centrality measures for a multivariable, and it includes more nodes like cache, mobile, deposit, wire, India, China, Switzerland, UAE, Nigeria, with their degree centrality, between the centrality and closeness centrality. Here, the accuracy for random forest is 0.83, meaning 83%. Uh, so here is a Leuven community detection graph, and these red one lines are the nodes of fraud indicate in Leuven community detection, and in Leiden community detection also. Here the red one lines are of fraud indicate lines. So this one is the network edge tables of source to target. So that uh, that was a that was a quick walkthrough. That was a quick walkthrough of how network analysis helps in AML detection. For more details, you can reach out to us at Infigo's Software Solution, Dublin, Ireland. You can also contact us via email at info@infosoftwaresolutions.com or on WhatsApp at +44 748 249 3885. Thank you.